Welcome to the examples for you, the second video. You better be watching these. Come on. All right, so all kidding aside, you had your example for you. As I look at this problem, I want to do a u substitution. I notice that I just have a trig functions whose angles are 1x. So the angle part is not the problem. It's the fact that we have a sine squared. So we do have a quantity being taken to a power. Remember that sine squared can be rewritten as sine of x to the second power. So then you can see, wait a minute, I've got a quantity being taken to a power. Now mind you, it's not a real quantity because it's just sine of x. Okay, so sine of x is our u. The derivative of sine of x is cosine of x dx. Now this is a very tricky problem because we're going to be integrating and differentiating. The derivative of sine is positive sine. The integral of sine is negative cosine. So it's going to be quite tricky. We'll have to keep our wits about us. So be very careful. Well, when I do a u substitution, look what happens. I get u squared du. I don't have to worry about sine at all anymore. So I'm going to integrate u squared, which would be u to the third over 3 plus c. And then I do need to make sure that I'm substituting out that u. Never circle in or box in an answer with a u. Not on free response. Okay. Our next example for you. Oh, mercy sakes. Looking at this one, I've got x to the third, I've got x squared, I've got secant squared. Goodness gracious, everybody has a power except the poor little dx, and the dx will not have a power. So when I'm looking at that, I don't even know what to even think about. When I look at it, look at the angle first. When you have a trig function, look at the angle. Well, the angle is an x to the third. I'm supposed to have a 1x. So that seems to be a problem right there. So that's my first problem. Well, I see secant squared, and I'm thinking, well, wait a minute, secant has a power, but wait, you know how to integrate secant squared. So secant squared is not the problem. The problem is my angle. So that's what u has to equal. Okay, so du is going to have to be 3x squared dx. Well, I have the x squared and the dx. I'm all out of 3's though. So I'm going to need to multiply, and it's all multiplied. I'm going to multiply the front by 1/3. That way I've only multiplied by 1. I haven't changed anything. Look at this cleanup job. Okay, the x squared times dx times 3, that's all du. Secant squared of x cubed, well, x cubed is u. So this nasty problem that was very confusing has become quite pleasant. So the integral of secant squared is tangent plus c. Don't forget your plus c's. Also, don't forget to substitute out. Remember, it's not all about you. These problems or everything else. Everything is not about you. little trig joke there. Okay. Oh, what a mess. I believe that's all the problems we have. Oh, nope, examples for you. Okay, so when we're looking for our u substitution, our u has to be, well, our trig function, our angle has to be a 1x, so the problem is that darn 3x. Ooh, this one's a good problem. My du is supposed to be a 3 dx. I have a 2 dx. I can't just add 1. All I can do is multiply by 1 or add 0. Adding 0 is not going to help. Multiplying by 1 is going to help because I need a 3. So I don't need the 2. Anything you don't need, move out. We don't need ya, we don't want ya. So now we have cosine of 3x dx. I need the 3, so I'm going to put the 3 in. I'm going to counteract that with the 1/3. Don't try to do everything at the same time because it gets all tangled up. Just do each step at a time. I didn't need the 2, move it out. I needed the 3, move it in. Make sure you're counteracting anything that you put in with its reciprocal. So now I have 2/3. I'm going from 0 to pi over 6. Okay. And I have everything that I need. Okay. So let's make our substitutions. Cosine of 3x, we're replacing that with a u. 3 dx is du. We now need to change our limits. So remember to change our limits. We're gonna start with the 0. So put the 0 in right there. So 3 times 0, still 0. The pi over 6, we're still going to put that in for our x. So 3 times pi over 6, that gives us pi over 2. So we'll integrate. So we'll have 2/3 times the sine of u. Remember, because we changed our limits, we don't ever have to go back to the x world. We'll put our pi over 2 in first, and then we'll put our 0 in. To integrate this all the way, we'll have sine of pi over 2 minus 2/3 sine of 0. That's just going to give me 2/3. The sine of pi over 2 is 1. The sine of 0 is 0. Okay. Now 16. 16 is a nice problem, if I have to say so myself, because I made them up. When I'm looking at that, wow, that's just crazy town. We have tangent of x, we have secant squared, we've got all kinds of things. We need to substitute somebody out because the square root of tangent and secant squared, I can't do both. So I need to ask myself, look at your tangent. Tangent, can I take the integral of tangent? No. But I can take the derivative of tangent. Ooh, what is the derivative of tangent? Secant squared. So it looks like tangent's going to be our u, because if I do secant squared as u, the derivative of secant squared, remember, is secant, or 2 secant to the 1 power times secant tangent. That's a lot of stuff we don't have. And we can't create x's. We can only create numbers because we can multiply by a 3 and then counteract that. We can't do the same thing with x's because x's are changing. So it looks like tangent's going to be our u. Which leaves secant squared as my du. So substituting all that in, I'm going to have u to the 1/2 power du, got to substitute them both out. And now we're going to put in our new limits. So if I put 0 in here for my x, I'm going to get tangent of 0, which is 0. Then I'm going to put pi over 4 in for my x, so the tangent of pi over 4 is 1. So now I'm ready to go ahead and integrate. So that's going to be u to the 3/2 power divided by 3/2, which is the same thing as multiplying by 2/3. Substituting out those limits means never having to go back. So if I put that 1 in for the u, and then I put the 0 in for the u, I'm going to end up with 2/3 again. Look at how different these problems were, but yet we got the same answer. Remember, it's just the area under the curve. And there's a lot of areas that could add up to equal the same value. Okay, so those were our examples for you. I will see you in class tomorrow.